Okay, here's the lesson for section 2.6, distance time graphs. Let's start by looking at what is a distance time graph. A distance time graph is a graph that shows an object's distance from a fixed point over a period of time. So this line here shows an object's distance from a fixed point over a period of time. So here's our fixed point right here, and then this line represents how far that point is, how far this object is from that point over a period of time. So if we want to know how far is the object from this fixed point right here at this unit of time right here, we look at our graph. We look at that point that lines up with that period of time, and then we look at what is the distance at that period of time. Okay, so it would be that distance here. So the object, whatever the unit of distance is right here, that would tell you how far away we are from this fixed point. Okay, so that would be the distance right there. Okay, so let's look at what the graph can look like of an object's distance from a fixed point or period of time, and what the shape of that graph means. So if the line, if we have a rising line, okay, the line goes up to the right, okay, that shows that the distance from a point is increasing as time increases. So a rising line shows that distance from a point increases as time increases. So as time is increasing, so as time is getting bigger, okay, as time is going by, the distance, so as time is increasing, the distance is also increasing. So the distance from our fixed point is also increasing. It's getting further away from that fixed point as time is increasing. If we have a line that goes down to the right, so a falling line, it shows the distance from a point decreases as time increases. Okay, so as time is increasing, so we're going to the right with time, as time is increasing, our distance from the fixed point is becoming less. Our distance is going down. It started off this far away, from our fixed point, and then we finished off here. So it finished off only this far away from our fixed point. So a falling line shows the distance from a point is decreasing. A horizontal line, okay, so a horizontal line shows that distance from a point remains constant. So this horizontal line shows that the distance, okay, is never changing. The y value of this line is never changing. It's never going up or down. As time is increasing, an object's distance from our fixed point down here is not changing. If the distance from a point is not changing, they must be just standing still. Okay? So a horizontal line shows the distance from a point remains constant. One other thing we need to talk about the rate of movement. Okay? The line can also show us how fast someone is moving. So the speed of a person affects the steepness of a graph. The steeper a line is, okay, the faster the rate of movement. And why is that? The steeper a line is, that means they're covering a greater distance in a shorter amount of time. So the greater the change in distances compared to time, the faster the speed is going to be. Because remember, speed is change in distance divided by change in time. So the greater the distances that you're covering, okay, that's going to give you a greater speed value in relation to time. So let's take a look at that. I've got two graphs here. One line that doesn't rise very much at all. It's a pretty shallow line. It's not steep. And I've got one here that's a very steep line. Okay? So which graph represents slow? Which one represents fast? Well, I know the steeper the line, the faster the movement. This line is clearly steeper. I'm covering a greater distance. Okay, I'm covering this whole amount of distance here in a very short amount of time. Okay? So that line is steeper. Therefore, this represents fast movement, because the change in distance divided by change in time is going to be a much greater value than this one, where I don't cover very much distance at all. I really only cover, you know, this much distance over a long period of time. So my change in distance divided by time is going to be a very small number. So that's going to be a slow speed. Now let's look at changes of rate of movement. Okay, so all graphs aren't always going to be linear. They're not always going to be moving at a constant speed or a steady pace like these ones are. These ones are moving at a constant speed. Okay, the speed is not changing. They're moving at the same speed the whole time. That's what the straight line indicates. Sometimes we'll have a nonlinear graph. So when we have a curve, that shows that the rate of movement is changing. So a curve can represent two things. It can represent an increase in the rate of movement. So this line starts off very shallow. Okay, so they're not moving fast at the beginning. Then it gradually gets steeper. So they're gradually getting faster. So that represents an acceleration. Now let's look at the opposite to that. A curve could also represent a decrease in the rate of movement. So it starts off very, very steep. And then as time increases, it gets less steep, less steep, less steep, less steep, until they're barely moving at all. Okay? So it starts out fast, gets slower. That represents a deceleration. So, like I said before, a straight line represents an object moving at a constant rate, or a steady pace, or a constant speed. Okay? The speed is not changing. The rate of movement is not changing. They're going at the same rate for this whole time. That's what a straight line indicates. So let's practice describing distance-time graphs. Okay? So a person walks in front of a motion sensor. Describe the motion that would produce each of the following graphs. So I've got this graph here. I'll notice, first thing I'm going to notice, it's a straight line. So I know they're moving at a constant pace. Okay? So the rate of movement isn't changing. They're moving at the same rate the whole time. So is that rate is it fast or is it slow? Well, let's look at the steepness of the line. So over a short period of time, they're covering quite a bit of distance. Okay, so it's a pretty steep line. So that means they have a pretty fast speed. And in what direction are they moving? Are they moving away from this fixed point, or are they moving towards it? Well, the distance is increasing as time is increasing. So their distance from that fixed point is increasing, so they're moving away. So how I would describe this, I would say the line is steep. So the person moves at a fast, steady pace away from the sensor. Their distance from the sensor is increasing, so they're moving away from it as time is increasing. And because it's steep, I know they're moving fast, and because it's straight, I know they're moving at a steady pace. All right, next ones. So I've got B. Once again, I've got a straight line, so I know they're moving at a steady pace. This line is not very steep. They're not covering very much distance. They're only covering a tiny little bit of distance over quite a long period of time. So it's a slow speed. It's a steady pace at a slow speed, and their distance from the fixed point, so the fixed point is here, and their distance from the fixed point is decreasing. It's going down. Distance is going down. Okay, so they're getting closer to that fixed point because their distance from that fixed point is decreasing. So they're moving at a slow, steady pace towards the sensor. And how I would describe that, so the person moves at a slow, steady pace towards the sensor, and that's fine. Now let's look at the next one. So C here. This one here, I notice I have a nonlinear graph. So it's a curve. I have to figure out, does that curve represent an acceleration or a deceleration? So as time is increasing, is this line getting steeper or is it getting less steep? Okay, so let's think about this. As time is increasing, it doesn't start out very steep. They're going pretty slow at first. Okay, and then as time keeps increasing, it gets even steeper and steeper and steeper and steeper. So the rate of movement is increasing gradually here. Okay, so it starts off very slow and then gets steeper, so it gets faster. Okay, and their distance from the point, they start off here, so they start off this far away from our fixed point, and then as time is increasing, they're getting the distance from the fixed point is increasing. Okay, so by the end, they're about this far from the fixed point. So distance from the fixed point is increasing, so they're moving away from it. So how I would describe this, I would say the curve indicates a change in speed, okay, because it's nonlinear, so they're not moving at a constant speed. The person moves away from the sensor because the distance is increasing as time increases. And I said they start off slowly at first and then gradually pick up speed. And you could add in here, you could call that an acceleration if you want. Okay. Let's describe the following graph that represents person distance from home over a period of time. So this graph has been divided into a few different sections. So we're going to have to describe each separate section. So I've got this section here, section AB. I've got this section here, section BC, this section here, CD, and this section here, DE. Okay, so I've got 4 different sections, and I'm going to describe each of those sections separately. So section 1, section AB, So what I want to do, I want to figure out, okay, first of all I want to know it's a straight line. So they're moving at a constant pace, okay, steady pace. And the distance is increasing, it's going up to the right, so that means they're moving away from the sensor. And the line is not very steep, so they're at a slow pace. So I'm going to say moving away from the sensor at a slow, steady pace. Alright, now let's look at line segment BC, the second section here. So once again, still a straight line, so they're going at a steady pace. Okay, there's no change in the rate of movement if we're looking at this isolated section here. Okay, they're going at a steady pace in this section right here. It is steeper than the first section, so a steeper line, remember, indicates a faster speed. So they're moving at a fast, steady pace, and as time is increasing, the distance from the fixed point is increasing, so distance from home is increasing. So I'm going to say they're moving at a fast, steady pace away from home. Okay? So I should, right in part AB here, I shouldn't have said the sensor away from, I should have said home, because the question tells us that we're talking about the fixed point is the person's home. So from moving away from home at a slow, steady pace. In BC, they're moving away from home still, distance is still increasing, at a fast, steady pace, because the line is a lot steeper in the second section. So, once again, moving away from home at a fast, steady pace. Let's look at part CD. So in part CD, it's a completely horizontal line. Okay, and hopefully I remember from before, a horizontal line shows no movement. Okay, the distance from home for this person is not increasing or decreasing during this section right here, from C to D. Okay, distance is not changing, so the person is not moving. So I would say part CD, no movement. Maybe the person is just sitting down, taking a break, whatever. DE, okay, now the line is falling down to the right. Okay, so I'm looking at this section right here. It's pretty steep, so they're moving pretty fast. But because it's falling down to the right, the distance from home is decreasing. So I know they're moving towards home. So they're moving towards home at a pretty fast, steady rate. It's a straight line, so it's a steady rate. So moving towards home at a fast, steady rate, or pace, or speed, whatever one of those synonyms you want to use there. Okay, so we've described that whole thing now. Okay, next question. Let's describe the motion represented by each of the following graphs. Okay, so now I've got some units of distance and units of time, so I can be a little more specific with their movement here. So I've got a straight line, so they're moving at a steady pace. And the line is falling down to the right, so I know they're moving towards the sensor because the distance is decreasing. The distance is decreasing as time is increasing, so they're moving towards the sensor. And the line is not very steep, so they're moving at a pretty slow pace. So what I would say, the person starts at a distance of 3 meters from the sensor, so they start at 3 meters away, right here, and they walk toward it at a slow, steady pace. They're walking towards the sensor, because near the end, they're less than 1 meter away. Okay, so they're clearly walking towards the sensor at a steady pace. Okay, and it's pretty slow because the line is not very steep. Next one, B. So they start at about 1.5 meters away from the sensor, and it's a straight line, so they're moving at a steady pace, and it's pretty steep, so they're moving at a fast, steady pace. And the distance, as time is increasing, the distance from the fixed point is increasing, so they're moving away from the sensor. So the person starts at a distance of 1.5 meters from the sensor and walks away from it at a fast, steady pace. C. So this one I have a curve, I have a nonlinear graph. So First of all, I know they're not moving at a steady rate. I need to figure out, are they accelerating or decelerating? So the line, they start off about 5 meters away from the sensor, and then the line starts off not very steep, and then as time is increasing, it gets steeper, 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 steeper. So they start off slow, and they gradually pick up speed. And then they start off 5 meters away from the sensor, and at the end, they end up right at the sensor, 0 meters away from the sensor. They end up right here, 0 meters from the sensor. So they're clearly moving towards the sensor. So the person starts at a distance of 5 meters away, and they walk toward it slowly at first, and then gradually pick up speed. Last one here. So I have a few different sections here. So they start 2 meters away from the sensor. Then I have a straight line, so they're moving at a steady pace. It's not very steep, so they're moving pretty slowly. So they're moving at a slow, steady pace away from the sensor. They start 2 meters away, and then after 5 seconds, they're now 4 meters away from the sensor. Okay, so they're moving away from the sensor at a slow, steady pace. And then for about 1-2 seconds, the distance from the sensor is not changing, so they're not moving at all. And then for the last couple seconds here, we have a steep line falling down to the right, and it's a straight line, so that tells me they're moving at a fast, constant pace towards the sensor. So here would be my summary of this one. They start at a distance of 2 meters from the sensor. They take 5 seconds, 1, 2, 3, 4, 5, to walk a slow, steady pace away from the sensor. They pause for 2 seconds, 1, 2. Then they walk at a fast, steady pace towards the sensor. There we go. So those are the few different sections of that graph. Okay. Now let's kind of try and put all of this together here. So Chris walks each day as part of his daily exercise. The graph shows his distance from home as he walks his route. Using the graph, give an explanation of what is occurring over Chris's walk. Include information about time, distance, direction, and speed during each segment. So to do this one, we're going to have to remember speed equals change in distance over change in time. So I've got my units of time, and I've got my units of distance here, so I should be able to calculate speed for each section of the graph here, and include that in my description of what's happening. So let's look at the first section, section AB, right here. So this section right here. I'll use a highlighter to highlight it for now. So I want just this section. So what I want to talk about, it's a straight line, so he's moving at a constant pace, and it's not very steep, so he's moving pretty slow. I can actually calculate the speed for that section, and as time is increasing, the distance from home are we doing? Distance from home, yep, is increasing. As time is increasing, his distance from home is increasing, so he's moving away from home at a slow, steady speed. But I'll be able to actually state what that speed is. So first of all, he is moving away from home at a slow, steady speed of, now let's figure out the speed. Speed is change in distance over change in time. So he starts here at 0 meters away from the sensor, and he ends up here at 200 meters away from the sensor. So my speed equals change in distance over change in time. So he moves 200 meters over, what is the time? It takes him, this segment starts at 0 minutes, and it goes to 5 minutes. So 200 meters in 5 minutes. That's a speed of 40 meters per minute. Okay, so he's moving away from home at a slow, steady pace of 40 meters per minute. All right, get rid of this just so I have some more room. Let's look at BC now. So section BC is this section right here. So this one's steeper, so he's moving faster for this one. It's still a straight line, so he's moving at a constant speed. his rate of movement isn't changing in this section here. He's still moving. It's straight line, so constant speed. It's steeper, so it's faster than this first section. And still, as time is increasing, his distance from home is still increasing. So he's still moving away from home at a constant fast speed of, we can actually calculate that. But I'll start off. So we'll do this one in blue. Once again, he is moving away from home at a fast, constant speed of, and let's calculate it. His speed equals his change in distance over his change in time. Well, let's figure out how far did he go. Well, he started 200 meters away. Each unit on here represents 200 meters. So he went 200, 400, 600, 800 meters in 5 minutes. So he went 800 meters in 5 minutes. That equals 160 meters per minute. So he's moving away from home at a fast, constant speed of 160 meters per minute. Good. Let's do part CD. I'll try and do this a bit quicker now. So CD is this section here. So in this section, once again, line is going up to the right, so he's moving away from home. It's not as steep, so he's moving slower, but it's a straight line, so it's a constant rate. And he goes to 400 meters in 5 minutes. So he goes 400 meters in 5 minutes. Let's calculate that speed. I'll just write it at the bottom here. So speed equals 400 meters in 5 minutes, so that's 80 meters a minute. So I can write, he moves, he's still moving away from home at a slow, he's moving slow this time, moving half as fast as before. So he's moving away from home. Well, it's faster than the beginning though. I won't even say it's slow or fast. I'm just going to say he's moving away from home at a speed of 80 meters a minute. At a speed of 80 meters per minute. Okay, let's do DE. For DE is probably the easiest one to do. If we look at section DE here, it's a completely horizontal line. I know a horizontal line shows no movement because the distance, as time is increasing, the distance from home is not increasing or decreasing at all. So there's no movement at all. So that's the easiest one to describe. Our DE, no movement. And one left, EF. EF is the first one where the line is now falling down to the right. That means the distance from home is now decreasing. So he is now moving towards home. At what speed is he moving towards home? Well, he moves 2, 4, 6, 8, 10, 12. He moves 1,400 meters in 5 minutes. So we can calculate that speed. He moves 1,400 meters in 5 minutes. So he's moving 1,400 meters in 5 minutes. That means he's moving at 280 meters per minute. So, and I know it's a straight line, so he's moving at a constant pace. So he's moving at a constant speed of 280 meters per minute. It's falling down to the right, so he's going towards home. So he's moving at that's a pretty fast pace. So he is moving towards home at a fast, constant speed of 280 meters per minute. And one more question after this. So that's it for that one. Let's do our last question now. Let's actually create a distance time graph. So create a graph that shows my distance from my own team's net while I'm playing hockey based on the following scenario. So I need to read the scenario and divide this into sections that I can make a distance time graph for. So I start with the puck in my own end. So I'm right by my own net. Keep in mind, this is a graph that shows my distance from my own team's net. So I start with the puck in my own end and skate away from the net towards the other team's end at a steady pace. Okay, so that'd be my first section. So here's my graph. I start in my own end. I'm going to assume I start right near my own net. Oh, I don't want to use highlighter. I'm going to use a straight line here to show that I'm moving at a steady pace. So I'm moving at a steady pace. I start in my own end, and I want to skate towards the other team's end as time is increasing. I'm going to make it fairly steep because I'm probably skating pretty quick here. And then let's look at what it says next. It says, at center ice, I get the puck stolen from myself. Okay, so that means that this line should stop about halfway. I'm going to assume this represents the entire distance of the rink. So this is my own end, and this is the other team's end. So I start my own end, and then I'm moving away. So about halfway is about right here. So that's good. That's about center ice. So I got my puck stolen there. So I'm furious, and I stop for a couple seconds to slam my stick on the ice in frustration. So right here, I stop. So I'm not going to move for a couple seconds. Slam my stick on the ice in frustration. So for a couple seconds, I have a straight horizontal line. Then, so I want to get rid of this highlighter right now. Whoops. This is more work than I anticipated to get rid of that highlighter. Okay, so I stopped, slammed my stick on the ice. Now I decide to chase down the guy who stole the puck from me. So I accelerate back towards my own net. So I'm going to accelerate back towards my own net. An acceleration, I know I'm going to have a curve. So an acceleration means that it starts off slow and then it gets steeper. So I'm going to start off slow, and then I'm going to accelerate. So it's going to curve down like that. So I accelerated back towards my own net to steal the puck back. And I stole the puck back. Then I slam on the brakes and skate at a fast, steady pace away from my own net towards the other team's net. That's it. It says I'm so fast that I get a breakaway and score. So let's draw that. So after I've stolen the puck back, I slam on the brakes and go at a fast, steady pace back towards the other team's net. I'll use a straight line to show it's a steady pace. And it says I'm going fast, so it has to be pretty steep. And I'm going to go all the way down and score. So that would be that graph there. So I start off carrying the puck from my own end at a pretty fast, steady pace. I get it stolen. I slam my stick on the ice, so I'm not moving for a bit. I just stop there and I'm frustrated. Then I accelerate back towards my own end to steal the puck back. I steal it back, and then move at a fast, steady pace all the way down to the other team's end to score a goal. And that's it for that. Okay, so that's it for distance time graphs. Make sure if you have any questions, you let me know.